Okay, we're going to get started. I don't know how this is going to work. Um, I've been studying what I want to make sure that I don't waste your time. I'd like to not keep you any longer than I need to. And it's not because, um, you know, I've got things to do and places to be and TV to watch. It has nothing to do with it. I want you to sign in, not because I'm going to take attendance. You don't have to sign in if you don't want to, but I want to know who whom I have reached out to. Whom I have reached out to. Right now, we have 8 people here. That's not a lot. I think what we're going to do at these reviews are going to be very helpful. The exam is basically the same exam we gave last semester. Um, so uh, we made it through last semester's exam. My students did. You will too. Do I like the exam? I guess whoever made it up likes it. It's not the exam that I would give. I'm recording this Zoom lesson so that I haven't decided whether, people that aren't here, don't count on me. If it doesn't work out, I've never recorded a Zoom lesson before. Now, my YouTubes are done through Zoom. Here's what we're planning to do in the next few days with you, and we'll do some maybe this weekend. And you can just respond if you need to. I'm going to talk today about problems that are going to carry a lot of point value because they're what I want to see if you can do. I'm going to also talk to you before the exam, give you a list of things that aren't on the exam. That's important. They have left out so many important things that it makes me wonder, well, anyway, I'm not going to get into it. So let me tell you, first of all, there are 13 questions. That is, they're numbered 1 through 13. And the exam is 12 pages long, front and back of 6 pieces of paper. The first page is where you put your name and where you sign the pledge. I'm going to even make part of the exam signing your name and signing the pledge be points on the exam. Because if you don't sign your name, I'm not coming looking for you. And if you don't sign the pledge, why? So it's 3 points. Also, I've told you about the 5 points if you submitted that Gen Ed question on your exam. Add 5 points to your exam. So probably got 7 points there. I checked last night. We were 1 student away from hitting the magic number of 70%. That makes me look good. I don't know what you'll say about me, but at least I've got you evaluating me. And so I told you, and we should, it only takes 1 more student, and they may have gotten it last night. I haven't checked this morning. But we were at 68%, I think, which is admirable. I kind of thought maybe this would happen. You've been very cooperative as a group. To have 27 people sit for test number 3 is unbelievable. Some of you talked to me about different things, and I've taken it to heart, and I am going to revamp this course in certain ways because I want to. One is, I believe, I haven't graded your test 3 yet, but that is a lot of material. I used to give 4 tests, but because of time, I went to 3 tests. And I think in the future, that won't affect you, but I'm going back to 4 because of the way I teach the class. It shouldn't be a problem. So what I want to talk to you today about is certain questions that I'm going to grade heavily. That is a lot of points. So listen, and you may want to take notes. Question number one has three parts to it. They are limits. Now, here's what you need to do on the limit problem. You need to plug in and see if you get an answer. Okay? And if you get 0 over something that's 0, that's an answer. 0 over 0 says you can't plug in. But if you get a number over 0, that means the limit doesn't exist. That's important. Keep that in mind. That's your reward for coming here today. If not, you will get a question there. If you get something over 0, that means no. I've been saying that since the beginning. I'm not teaching the test. I refuse to teach a test. The thing of it is, I have taught so much more that's on this test exam. Remember, if you take a limit and you get infinity over infinity, you can use L'Hopital's rule. But if it's a polynomial of a polynomial, you can use this fact. If the degree of the numerator is less than the degree of the denominator, it's 0. If the degree of the numerator is less than the degree of the denominator is less than the degree of the numerator, you get infinity. If they're the same, you get the leading coefficient over the leading coefficient. Now, it's not necessarily the first coefficient. The leading coefficient is the coefficient. So let's say you have anything x to the 5th over some number like 13 x to the 5th, and you've got in the denominator, you got 12 x to the 5th, and it's 13 over 12. I'm not just talking here. I've got the exam in front of me. The third limit, do with it what you can. I'm going to make it worth a point. Okay? Do with it what you can. I'm going to make it worth a point. So you're going to have a limit problem. Plug in to see if you get an answer. If you get 0 in the denominator and a non-zero in the numerator, limit doesn't exist. And if you get infinity over infinity, you can either use L'Hopital's rule, or you can use that special rule, which is the degree of the numerator, degree of the denominator, and test it that way. That would be my preferred way. Okay. Now, you understand that's what you're going to need to do with limits. I'm done. There's no limits of trig functions and yada, yada, yada. The second question is on the derivative, but not the definition of the derivative. The directions are find dy dx or y prime. You do not need to simplify your answer. So I would, to save time, just go ahead and take the derivative and leave it. They want to see if you can do the quotient rule. So apply the quotient rule and you will get credit for it from me. They don't give a simple quotient, but that doesn't matter. Then they give you a product rule. One of the products is obscure function. I'm not, that if you get the function derivative wrong, I'll take off something for that, but I want to see if you know the product rule. what I want to make sure is, on the quotient rule, you don't just take the derivative of the numerator and derivative of the denominator and divide the two. I want to see if you do low d high minus high d low over low squared. Don't simplify your answer. Leave the whole thing, whatever it's squared, put a square around it, parentheses squared, the whole thing. I'll be happy. Same thing with the product rule. They have one that's things, we had a problem like this that threw you, most all of you, like x to the e to the x, e squared and stuff like that. X to the e is e times x to the x minus 1. E to the x is e to the x. X to the e is e times x to the e minus 1. And e cubed is just 0, derivative. They got something, you've had this. This will be fun. I'm not worried about you doing that. But it's not, A and B, product rule and quotient rule, or quotient rule and product rule will carry a lot. The C, we'll see what you get with it. D, they want you to take the derivative of one of your inverse trig functions. So know those formulas. Derivative of the inverse tangent is the derivative of the angle over 1 plus the angle squared. Don't try to just write it as 1 over angle squared, 1 plus the angle squared. Don't try to get fancy with it. If it's the inverse sine, it's a derivative of the angle. That's usually pretty easy, over the square root of 1 minus the angle squared. And then they have an implicit. This is the fifth problem of derivative. It's an implicit. One of the terms is a product, so do the product rule when you do it. But I want to see if you know implicit. I'll take off something if you have an error, but I'm thinking that this problem, this page is going to be somewhat around A, B, and the last one, implicit. They're probably going to be somewhere between 8 and 10 points apiece. So make sure you know your quotient rule. Make sure you know. I'm telling you, all of you this. I want those of you that have an A to have a chance to keep your A. And I want those of you who are struggling to not slide backwards. That's not my job. We've done a lot of work together this semester. So we got 12 people here so far. So I've talked about limits. That's one of the questions, 3 things on limits. I've talked about the derivative. And the fact that you need to know the quotient rule. Don't come in without knowing the quotient rule. Product rule. Don't come in. If you can't do implicit, no sense in it. The other stuff, you lose something. Not everybody's going to get an A on the exam. Very few people do make an A on the exam. That's why, but it's not all your work. I'm moving right along. I'm skipping some pages because we're going to talk about some actual problems. I'm now over to page 7 on the exam. They give you a polynomial. And they ask you, well, give the interval of increasing and decreasing, interval of concavity. So here's what you do. Take the first derivative, set it equal to 0, and solve. It's not a hard derivative to take. Find your critical numbers. You're going to get 2. Okay. Use the first derivative test. That is, draw your sine graph and determine whether it's increasing or decreasing. And then from that, you will be able to tell A says give the interval where it's increasing, and B will tell you whether it's decreasing. You'll also may find if it's not increasing or decreasing, then that point is a PI. Then take the second derivative and set that equal to 0. And that will give you your PIs. Draw a sign graph for your PIs. Take a number to the left of your first PI and put it into the second derivative, and one to the right. Okay. And determine what's happening. If it goes from negative to the left, negative means frowny face or concave down. Positive means smiley face, concave up. And so just look at it and say, oh, it's up to 3 or whatever the number is. Up to 3, it's negative, it's concave down. Past 3, it's concave upward. It's positive, it's negative, and it's concave up, and just handle that. That should be an easy question. They need to see work, but you can, of course, check yourself by looking at the graph. But that would be not just to put down the answer without seeing something. I need to see that you've tested. I need to see that you have found mathematically the critical numbers by taking the first derivative and setting equals 0 and testing it with the first derivative test. I would then take the second derivative and set that equal to 0. Hopefully find your PIs and draw the sign graph for that. If you want to plug in numbers, which some of you do, that's okay. But so that one's going to be worth right much. So question number 2, which is your derivative, quotient rule, product rule, implicit, is going to be a lot. And so is this question, where you have to find the critical numbers and the PIs. And I'll be giving a lot of part credit. I'm now over to page 9. I've got it in front of me. They're going to give you a simple polynomial and ask you to find the definite integration. So you're going to find the antiderivative and put in your top number, then put in your bottom number, do the arithmetic, and get your answer. And then they have one that only one, you've got to use U substitution. U substitution. So what you will do is let U be the glob. And it's going to probably be what's left over. It's not hard. When you're going to get something like 1 over the cube root of U, or 1 over the square root of U, or 1 over U squared, and integrate. It's not a definite integral, so you're not going to have to use the change of variable technique. And that basically is all I want to talk about today. You say, well, it's only 11:20. I wasted my time. I don't think so. We're talking about, based on what I've told you, probably at least I've talked about probably 60 points on the exam. I don't think that's wasting your time. I will email you for next time we can. I'm going to see who was here, and we'll see whether this is worth keeping, whether this, I've never done a recording of because I don't like to. because they're kind of offhand. Now, I love Zoom for making my YouTubes. I'm a big fan of YouTube. Anyway, thank you for being here. I tried to figure out most exams are over by 11 and the second exam does not start. Any of these I'll do. Now, let's say you're on campus and you're getting ready to go into an exam. Tune in. You don't have to stay home. iPhone, tune in. Let me know what you think. Feedback. And we're going to make it. And so what I'll be doing next time is, and I'm probably going to see if I can do a Zoom tomorrow, and we're going to take some problems, not the problems, but one like it, and make sure you understand what they're asking. Here's the thing. There's not a thing on this exam that I have not taught you. But the thing of it is, they've tried to, it's almost like trying to identify somebody that you know, but they're wearing a Halloween mask or something like that. In other words, why? But anyway, have a good afternoon. And I'll email you probably tomorrow about the same time. Okay? Thank you.
Mr. Childress, I have a question.
Yes.
Just to be clear, I got everything down. So you said that for the section of limits, there would be 3 problems for that.
Mm-hmm.
So there'd be one where you would plug in and then you potentially would get,
Well, you want to always plug in, right?
yeah, but you would get one that would potentially be that it doesn't exist.
Right.
And then one where you would have a polynomial, or so you could potentially use Hopital's rule or the degree rule.
You got it.
And then the third limit problem, you just said do with it.
Yeah, do with what you can. Yes. And it's going to be worth a point.
Okay. And then you said there would be no limits on trig functions, right?
No, I don't see any. Let me run through quickly. Da da da. Well, that one that I'm only count 1 point does have a trig function in it, but I don't think that's going to. And I'm trying to see. There's no other limits. This is one of the things. Limits is so big in this course. You notice how long we spent a whole month on limits, and that's all they gave. And they've got something. They give you some information on limits, and they say sketch. We'll talk about those there, but that's you got it. Okay.
Okay, and then there was also one that for the derivative section. There would be one that you would use the quotient rule, one where you would use the product rule, and then you said there was one where you would say take e to the x. There's an e to the x problem.
Yeah, well, they're just trying to see if you would like, if I gave you 2 to the 4th power, what's the derivative? Well, it's not 4 times 2 cubed because 2 to the 4th is a number and the derivative of a number is 0 type thing.
Yeah.
It's a little tricky. You're not going to have trouble with that. Okay, but that's not going to, no, then there's an implicit.
And then there's an implicit problem that you would use the product rule with, right?
It had a product in it, but you don't worry, just, you implicit, take the derivative, everything. If it's a y term, put a y prime with it, with x, and y primes to the left, non-y primes and factor out and get the answer. But there is a product in it. But that, if you miss the product, I'm not going to throw it out. I'm going to give you credit for saying, hey, this student knows, but they got tricked by the product. And it's not a hard product. Okay. I'm probably giving you too much information, but this is the most horrific for all the work we've put into it. So we're fine. And then what else did you want to know?
And then just to be clear, there would be page 7, there'd be a problem that you would have the interval, and you mean a polynomial, so you're just finding the increase decrease with the first derivative, use a critical numbers, sign chart, And then if you do the first derivative test and you get a number that it isn't, it's like negative on both sides or positive on both sides, then you would not use that for increase or decrease. That would be a potential PI, and you would test that in the
Right.
second derivative test,
Right.
right?
Right, you got
Okay.
it. You're right.
Okay, and then for page 9, that we would have a simple polynomial, and it would be to find the definite integration, right?
Got it.
And then one problem with U substitution, but it's
And
not a definite integral.
you got it.
Okay.
Thank you.
Okay.
Makes me feel better.
Okay. Okay, just wanted to make sure I did everything, got everything down correctly.
You got it. Thank you.
Okay. Thank you, Mr. Childress.
Thank you.
Mr. C,
Uh-huh.
I have a question.
I got you.
I just want to like double check what time is our exam on Tuesday?
Hold on.
Mhm.
I can't get to it. I will be sending you a reminder. I'm recording this thing, and it says that I can't leave my screen while I'm recording. So I was going to go look it up. I think it's in the afternoon, I believe, somewhere around 2 o'clock. But all right.
Okay.
Okay. It's next Tuesday.
Okay. Thank you.
Okay. You're welcome.
Professor,
Yes, Anton.
how are you doing?
Anton, I'm always doing well.
Good, good. Good to hear. Will you provide us an like practice exam or similar
Nope.
question? Not?
No.
That,
No.
just this, okay.
I just can't. That would be too hard to put together.
Understand.
All right.
Thank you.
Thank you.
Have a wonderful day.